I'm very pleased to welcome Christopher Costello, who's a professor of environmental and resource economics at the Bren School of Environmental Science and Management at the University of California at Santa Barbara. So Chris has had a very successful academic career, starting with his BSc in Environmental Economics and Policy in California, then his master's in Agricultural and Resource Economics in Oregon, and then back to California for his PhD, and where he moved straight from there on to Santa Barbara as an associate professor. And by all accounts, he's been quite busy since then. Chris's areas of interest include environmental and resource economics, obviously, dynamic optimization, decision-making under uncertainty, and we all know how uncertain things are, no matter how much non-economists like to ask us to predict the future. There's always a limit to our capability to do that. Incomplete property rights, something that we're very familiar with in fishing. Environmental markets, spatial, public economics. I saw something about public bads, which I'd be very keen to hear more about. So if you want to, you can look up on the internet and see a very long list of research papers that Chris has published in esteemed journals, and he's collaborated with a lot of highly respected researchers and authors that will be familiar to us in the audience. Chris is also involved in lots of different organizations on an advisory or board capacity, such as the Environmental Defense Fund, the Monterey Bay Aquarium, and another long list of associations and organizations that have benefited from his input. So today I'm really pleased Chris is going to talk to us about incorporating spatial consideration in fisheries management and policy. And obviously that's highly relevant to a lot of European areas where we don't have any defined output limits on our fisheries, especially in the Mediterranean. So spatial considerations are particularly important. So thank you very much. Welcome to Chris.
Okay, thank you so much, Hazel. It's a real pleasure to be here. It's an honor to be in front of my peers, and I have to say it's a little bit intimidating. And I'm standing between you and a coffee break, so I'll try to make this relatively brief and hopefully keep you awake. But Hazel asked me to leave a little bit of time at the end in case there are any questions. I want to just start by thanking the organizing committee and the scientific committee. Loretta, thank you very much, and Gianluigi has been a pleasure to work with. Thank you very much. The words earlier from Signore Amendola about the weather brought me back to California, where we're having a drought, which means there's no rain for 2 years. So it's actually a pleasure to be here. And I'm here with my wife, and we actually stood out in the rain and said, this is just glorious last night. So, I guess there's two ways to look at that. What I'd like to do today is just spend a little bit of time drawing on some work that I've done, but also work that my colleagues have done, and some work you have done, and work that others have done. But I think at the end of the day, I'll raise more questions than provide answers, because I think this issue of how and when and why to incorporate space into our thinking as fisheries economists is really an unanswered question. I think we've gotten a start on that, and over the last 10 years or so, there have been some, I think, very interesting contributions and new insights about this. But I think this is just really the beginning of how we do this. And much of what I've done and others have done draws on interdisciplinary work. And the discussions earlier about Jacques Weber, I had the pleasure of meeting Jacques about 10 years ago. This isn't planned because I didn't know people were going to talk about Jacques Weber. But it was really a wonderful meeting in Paris, and I know that he ran the Institute for Biodiversity there, and he gave me some great advice 10 years ago about my career, and so I just want to kind of take a minute to honor him. So I also want to start, before I click through to the next slide, to give you a sense of my own view on the future of fisheries economics, not really about space, but just in general. A team at my university with a number of other universities has just finished an analysis of global fisheries the current status of those fisheries, trying to estimate the status both in developing and developed countries, but also estimating some projections into the future about what is possible under different future trajectories in Europe, but also elsewhere. And my take-home message from that is really a message for hope. I think that many fisheries of the world have turned the corner. I think 10 years ago, it was a pretty dismal picture, and the front page of the New York Times actually said "a future without fish." Many of you remember that from Boris Worm's paper in 2006. And I really don't think that's the case anymore, in large part because economists have played such a prominent role in influencing policy. So I commend you on that, and I think that there's a lot of work to be done, obviously, but I feel that the message is definitely one of hope. So let's move to space. These are the 4 things I'd like to do today. The first thing is to describe what I would regard as the spatial features of fish. So what is the compelling argument for why we want to think about space? I mean, if you go back to the sort of canonical papers in resource economics about fish, they really said nothing about space. They were primarily, I mean, there were a few exceptions, but primarily there was sort of one aspatial fish stock that we were going to manage. And I think that's still appropriate for addressing a number of questions. But as we move into more and more finely tuned policy questions and finely tuned fishing policies and things like that, I think there is going to be a case for incorporating space in fisheries management and policy. And I'll talk about what those arguments are in a minute. The second thing is to then use that as a motivation for why we want to think about policy in space, and really some of the key policy questions having to do with space. We had a beautiful, many of us had a beautiful ceremony last night in the gardens, the Minerva Gardens, which was just a spectacular venue, as is this, by the way, especially for someone coming from California. This is not so traditional. So we were, I think last night was a great opening for this Congress, and I had a chance to speak with many of you who are really deeply ingrained in the policy of fisheries in the EU. And time after time, people, without even really knowing that I was going to be speaking about space, people referred to issues of space in how they're having to think about policy design. So I'd like to sort of call your attention to some of those key policy questions, and I'm sure there are many that I don't have listed. Third, I want to talk about research innovations. So these are some things that the community has produced over the last decade or two that I think can really help us move forward on addressing those policy questions. And finally, I'd like to just tee up some new questions. These are things that haven't been answered or maybe have only been partially answered. And I think at least I think of this as a research agenda for the future. Okay, so what are the fundamental features of fisheries that involve space? Now, I'm almost sure this won't work because this involves technology, but actually it looks like it is going to work. So about 10 years ago, I was sitting in my office in Santa Barbara and my phone rang, and it was an ecologist colleague of mine from across campus, and he said, "We just got $2 million from the National Science Foundation to study flow, fish, and fishing. And we'd like you to be part of this big interdisciplinary project." And I kind of said, well, what is flow, fish, and fishing? I don't understand where you're going with this. And he sent me this video over email. Okay, so I'm going to try to play it for you now. And he said, we've been able to produce with real data from, so this is where I live, this is in Santa Barbara. The black dots are islands, the black blobs, and then each little dot is a simulation of the larvae of a fish that was spawned out on that island. And they use real data from ocean currents to simulate where these larvae are moved around in space. And he said, if we have this basic scientific insight that fish move. And of course, I chuckled. But it's not just that we know they move, we know where they move, we know how they move, we know how long it takes to get from point A to point B. And then he starts going on and on about all these ecological concepts like pelagic larval duration, which you may or may not be familiar with, but this is the idea that when an egg is released into the water, it drifts around for only so long until it settles. So if you can model where it is on day 37, and you know that it settles on day 37, then you know how connected this place is to that place. And this was the basic insight that brought them to the idea that maybe we should be thinking about spatial management of fisheries now that we're armed with this kind of information. And people like Barbara Bloch, who's another scientist, have put actual tracking devices, and many of you may be familiar with this work or other similar work. They put actual tracking devices on adult fish and then follow them around. And they know sort of more or less where these fish are moving. So it's not just that we know where fish move, we have really good scientific evidence about how they move, when they move, and perhaps why they move, which might help inform policy design. And I'm going to come back to this insight in a minute when I talk about policy, but I think this is particularly important when you have spatial property rights, as we do in the EU with exclusive economic zones, and as we do in, let's say, Vietnam or Indonesia with spatial property rights to different communities. So I think these lessons carry over across very large scales and very small scales. Okay, the second insight is that fishermen move. And we all know this. We know, Jim Weiland has a number of very interesting papers on this, and his former students have worked on this a lot. Some of you have worked on this. And this is a picture from a port in China. I've recently had a project in China and visited this port. And the way that fisheries are managed in China, more or less, is with a 3-month closed season in the summer. There are very few other restrictions. Okay, so it's a very, very simple set of fishery management institutions. And this was opening day in September when the trawl fleet leaves the harbor and exits to go out into the ocean to go fishing. So we have a sense that fish move, we have a sense that fishermen move. And I think putting those two things together and thinking about the spatial movement and the incentives that fishermen have to go to different places is a promising area for research, and I'll return to that in a minute. Okay, this one's interesting. Data are just vastly improving. And I'm sure you're all familiar with this in different ways. This is just a screenshot of something called the Global Fishing Watch. How many of you have seen this thing? Okay, it's really new, and I'm just sort of becoming familiar with it. This is just one example, but okay, this is a project from Google and Oceana. It's a collaboration where they're actually trying to track trawl vessel movement all over the world. And you can zoom in and you can look historically, and you can look at where marine reserves are and look at the concentration of fishing effort around the marine reserves, how people move, and then ideally potentially match that effort data with catch data. So these are kinds of data that we've just never ever had access to. This is sort of fisherman movement data, but there are also new data on habitat. Many of you, I think, are involved in habitat mapping, for example, and mapping the location of spawning sites and things like that. So all of these data are becoming available, and that potential is only going to grow, which I think can contribute to policymaking. And we'll talk about why and how that might occur in a few minutes. This one's a big one, and it's more of a conceptual idea that property rights change incentives. And of course, we all know that as economists, but really taking that seriously as we design fisheries policy is going to be important. And the EU, there's no better place on the planet, in my opinion, to study this than the EU, because you're sort of part of the test case right now. And I know that there are different implementations of property rights around the EU, so I think it's just a great laboratory for economists to study how this occurs. And this is just meant to be a stylized view of this, but in the American West, where ranching is a really big issue, you put your fence up, one area is grazed, the other area is not grazed, that changes incentives, and the same sort of thing can happen in the water. This is from a fishery in Alaska that lacks property rights, and it's more or less a race to fish. Okay, many of you have probably seen this photo before. Okay, the next rationale for why we might want to start thinking about space has to do with climate change. And I really think this is undervalued by our community, and there's a lot of rich research opportunities here. So we're learning that climate change is likely to have spatial consequences, and this is another video. It's my last video, I promise. But this was made by some oceanography colleagues, and what they did is they went back in time and looked at areas or points in time when we had warm water and cold water, and looked at how it changed the flow of water and the temperature of water in different parts of the ocean. And this is just a simulation they produced. But it gives you the sense that we could experience very dramatic differences in temperature, and with those differences in temperature are likely to be associated different changes in species ranges. And this is a paper by William Chung and his colleagues, I think in Nature recently, that talked about changes in productivity in different parts of the ocean. It's not that everybody gets worse off under climate change, it's that species ranges shift and productivity changes in a directional way. It's not just more random, more stochastic, it's that it actually moves in a predictable way, and some places become more productive, and we want to think about how to anticipate that and how management ought to change. Some places become less productive. And furthermore, the species that used to be living in country A will now be living in country B. And this, I think, changes incentives and changes how we want to think about management. Okay, so that's sort of the backdrop and at least my own personal motivation. And of course, there are lots of other rationales, but those are some of the main ones for why we might want to think about space. What I'd like to turn to now is just a discussion of some of the policy questions, at least the ones that I've been involved with, and I'm sure there are many others, that will require spatial analysis in order to answer them. Okay. So, and these will be quite broad, but with each of these there are specific examples, and we could get into these now, or perhaps in the Q&A, if you have questions on these, we could return to them. I think this is really a big one. Can privatization solve the tragedy of the commons? And I think the literature is actually hasn't quite been conclusive on this. I think there's a sense that ITQs as one form of privatization might reduce the race to fish, for example, and in that sense may solve the tragedy of the commons. But I think there are problems with ITQs, and if they're not implemented properly, they may in fact not end the race to fish. Okay, and if there are questions on that, we can discuss it. But with respect to the spatial question, I think property rights, the way I think of property rights as spatial property rights. So these are things like turfs, typically in a developing world context, or exclusive economic zones in the rest of the world at a large scale. Under what conditions will privatization actually create the right incentives? And I think when you think about spatial property rights, it won't always be the case. And I'll come back to this in a minute. But if you put my first observation, that fish move, together with spatial property rights, the economic expectation is, in fact, that privatization will not solve the tragedy of the commons, because everybody has an incentive to over-extract, because if I don't catch the fish, they will be swimming over to your area. And so I think there's an issue there that is amenable to economic analysis and sort of game theoretic analysis. Okay, second, are there spatial solutions to bycatch problems? Now I know bycatch is a really important issue in the EU right now, and as it is in much of the world. And I think there are lots of different ways people think about bycatch, and one of them is, can you use space to solve the problem? Can you have different regulations in different parts of the ocean, for example? I'm going to talk about in a minute one possible solution to this that maybe is new, that you have areas that protect bycatch species and areas where you don't worry about bycatch species. Sort of the idea of using a marine reserve to solve the bycatch problem. That's a potential spatial solution to bycatch problems, and we'll get into that in a minute. Okay, at least in the United States, and I think increasingly in much of the rest of the world, marine reserves are a really big conservation issue. So a lot of conservationists look to land and say, we have national parks, we have big conservation zones, why shouldn't we have those in the ocean? And we have a very small fraction of the ocean that's protected in marine reserves. And this has become a really nice motivation for lots of economics papers about what are the effects of marine reserves on fisheries. Another question is, what are the effects of marine reserves on spatial non-cooperation across different property rights owners? So I'll discuss that in a minute. I think fundamentally this is the EU's issue, or one of the EU's issues. When and how do you, and to what extent do you devolve management from some central authority locally? And that could be to a member state, but it also, if you're in Indonesia, that could be, when do you tell the community, here's your turf, you get to manage it? So what are the pros and cons of taking central control and turning it into local control? And there have been some interesting papers on that. Marine conservation and marine resource economics, I think, have often been in conflict with one another. There was a whole series of papers in the late 90s about, the only reason you would ever want a marine reserve is for pure conservation reasons. It could never benefit the economy. That was one sort of idea. And I want to flip that on its head, and I'll discuss this more in a minute. But as soon as you start to buy into a property rights-based fisheries economy, I think that provides a platform for investment in conservation. Okay? And I'll discuss different ways that could occur, but I'll just quickly say now that, does anybody know who the largest landowner on the planet is? Aside from the Queen of England. It's the Nature Conservancy. Okay, this is a private conservation organization that goes and buys land in markets and sets it aside for conservation. It's the largest private landholder in the world. And the reason it's the largest private landholder in the world is that there are property rights on land, and there's an ability to engage in private conservation. If you want to engage in marine conservation, you can't go buy something right now. You have to go through a lengthy political process and make a lot of enemies to try to create a closed area. And I want to just discuss the possibility of the platform for investment that property rights might provide in a spatial context. I want to hearken back to my observation about climate change and changing species distributions and ask, are the current set of institutions that we employ in fisheries management climate proof? This is a term that has now been coined by scientists, but are they climate proof in the sense that can we rely on the same set of institutions in 50 years that we rely on now? Or will things change enough that we can't rely on those? Okay, and I think for some institutions, I think the answer is yes, we can rely on them. And for others, I think the answer is no. And we'd like to know which is which so that we could reform things now in anticipation of those effects. And finally, I'd like to just briefly touch on this, I think, emerging issue of marine spatial planning. There are multiple different uses of the same ocean space. So aquaculture, shipping, oil and gas extraction, you name it, there are probably 100 of them. And often these are in conflict with one another. Is there any sort of framework that economists can provide to help think about those trade-offs and think about making efficient public decisions about marine spatial planning? Okay. All right, so let me turn to my third point about recent innovations. Now, I could go on and probably pick papers that all of you have written and, discuss them in detail because I find this stuff so fascinating. I've just picked a few examples of these things to kind of motivate the idea that economists aren't so far behind. We're taking these observations, we're taking these policy questions seriously, using them as a motivation for research papers, and making a little bit of headway. I think there's a lot of room for improvement and future work, but I want to just highlight some of the innovations that have occurred. And I also maybe just point out that from my point of view in reading the literature, I think fisheries economists are probably the best example in the entire economics discipline of using current policy questions to motivate economic research. I mean, I'd say 80% of papers in fisheries economics, you read the first paragraph and they're going to talk about a current policy debate and how their research contributes to that policy debate. And that just isn't true for most other branches of economics. So I think that's a great position for us to be in. Okay, let me take you back to my very first slide, the funny little video with the dots moving around. The ecologist that sent me that video, we then embarked on this project, and the other economist on that project was a guy, Steve Pulaski. Some of you might know Steve. And Steve flew out to Santa Barbara, and we spent a week, and we said, okay, we're going to try to crack this problem. If these ecologists can really give us spatial maps of how every point A is connected to every point Z, what does that imply for optimal spatial management? So we worked out kind of what ecologists call a meta-population approach to this, and it became this enormous, very unwieldy optimization problem. Okay, imagine you've got 1,000 different points in space. You know how all the places are connected through this dispersal of fish, and maybe you even know something about habitat or growth conditions in all the different places. So every place can be different. They're all connected in this heterogeneous way, and economists are supposed to optimize this and come up with the, quote, optimal spatial management of this extremely heterogeneous, spatially connected system, right? So the first thing Steve and I thought was, okay, there's no way you could get analytical traction on this. Let's try to create kind of a numerical approach to doing this. But of course, if you're a dynamic optimization person, you'll quickly realize that, with 100 or 1,000 state variables, there's just no hope of actually solving a dynamic optimization of that size. And then we thought again, and we said, okay, maybe under some fairly reasonable assumptions, we can solve this problem analytically. And we did. So we took that problem, and I meant to say at the beginning that I asked a colleague for advice on how to give a keynote, and he said, don't put any words on your slides, just put pretty pictures to keep people awake. So I tried to take that advice. So these are supposed to be pretty pictures. So we took that stuff that our science colleagues gave us, and we developed a theoretical approach for solving that. So we actually wrote a paper that said, here's exactly how much to harvest here versus there, and under what conditions. Okay, and so that really gave us a framework, a theoretical economic framework for optimizing a spatial system. We were then approached by the state of California to do this, to apply this framework. And this is a picture of one of the maps that we created for them. And they took our advice. So they actually took the optimization framework that we provided and changed the way they managed the local fisheries. Okay? And the idea was to really try to take account of these sources and sinks of different fish movement. So it can be done theoretically, and the theory can be applied in practice. A related concept is the idea of marine reserve design. Now, one approach to marine reserve design, and it's the one taken by Pew and and National Geographic Society, the guys that are out there creating these enormous marine reserves. It seems like every 6 months you open up the newspaper and someone says, oh, the world's largest marine reserve has just been created, and it's in some place you've never heard of and you'll never go, but sort of interesting. And they, more or less, they go and they convince governments that they really ought to close a quarter of their EEZ to fishing. But there's no more really thought put into where those things go. I think at a more local scale, as we are interested in economic outcomes from fisheries, we have to be pretty thoughtful about marine reserve design. But this can be coupled into these kinds of spatial models. And so we've done that, and this is a process that took place also in California, where they closed about 25% of the state's waters So in the United States, the state has jurisdiction out to 3 miles, and then federal waters go out to 200 miles. So this is in that 3-mile zone. About 20 or 25% is closed. And they actually used these models to evaluate proposals that were put forth by stakeholders. So this is one approach to marine reserve design. You get stakeholders to propose ideas. You have economic or bioeconomic models that can run those proposals through and discuss the pros and cons of different designs, and ultimately a design is chosen. If you take these sort of very developed world concepts and say, well, what about, Southeast Asia, or what about Latin America? How do you think about spatial management of those resources? It's very unlikely that you're going to have these highly detailed spatial maps or spatial models of larval dispersal and all this kinds of stuff that we have in California. And one of the approaches that's been used, I think with some good success, are people getting feedback? Some good success, is the idea of a turf. And this is a spatial property right in the ocean. Chile is the poster child for turfs. They have over 700 of these things along the coast. And these range in size from, sort of roughly the size of this city block to much larger. They're privately owned by a concession. Usually it's a group of people that own them and manage them. There have been a lot of studies that show that they're managed really well. So if you compare open access areas, this is from Stefan Gelsich's work. If you don't know Stefan, he's a really interesting guy. And they compare open access areas, the abundance in turfs and the abundance in no-take marine reserves, and found that the turf owners were building up the abundance of these species in order to maximize profits. So it's in line with the bioeconomic approach that we would have taken. And this is empirical evidence that the fishermen actually behave this way. Now, an interesting point here is that these are sedentary species. So they don't swim around like the tuna picture I showed you earlier. It's called a loco, and it's like a snail that more or less stays in the turf. So it can be managed, think of it like a tree growing underwater, okay? It sort of grows, and you're going to let it grow until its growth rate equals the discount rate, and then you're going to catch it, more or less, if you know the Faustman model. So that's what these guys are doing, and they're doing it in many cases with great success. One interesting thing that has grown out of this is that now that these fishermen have exclusive access to these areas and they're owned, they can engage in what I call private conservation, and I think I've got this here. And what I mean by private conservation is, in principle, I could approach a turf owner in Chile and ask and pay them some money, and in exchange they could cut their catch rate in half, or potentially cut their catch rate to 0. And this may sound crazy, but it's actually happening. So I know of a case in Chile where a marine conservation organization has done this. They've gone to different turfs. They've written a contract for them to stop fishing. And instead, the fishermen go out and do things like they go diving and they do surveys of the fish abundance, and they try to learn things for the scientific community. So this is a totally different approach than going out and trying to convince a government to close its waters. This was a paper that Dan Caffeine and I wrote where we took data from the California coast and did a thought experiment. We said, suppose you had these turfs, so each cell is a hypothetical turf, and we asked, what if you had the ability to go buy these turfs and close them for private conservation? If a conservation group could actually go do this, where would they go and what would it cost to do that? And the hashed areas are our prediction of where these conservation groups would want to go. Also in the developing world, you can think, it turns out many institutions are not as precise as I've mentioned. Often it's the case that you have an open access fishery, and then there's a sort of a partial enclosure. So part of an open access area will be granted to a community to manage, for example. And we call this partial enclosure of the commons. And we went and looked through the literature, and there wasn't a single paper on this from us. We can blame ourselves. But it's happening all over Asia. It's happening all over Latin America. that there are open access fisheries and then small chunks are carved out and granted to a community to manage. And this has never received any economic analysis, okay, that we could find. So we did some economic analysis on this and found sort of, for example, the conditions under which that will lead to a Pareto improvement, or the conditions under which that could lead to a first best, or perhaps cases where that won't do any good at all. For example, if fish move around too much. Okay, this one's a little bit crazy, but this is an idea that if you have two turfs and you have fish moving around, then there's an incentive to over-extract. And there's been a lot of empirical evidence on this on the high seas, but also across exclusive economic zones. And there's been a lot of theoretical research on this when you have many turfs that have, spatial exclusivity. And so we came up with this idea, could you put a marine reserve in between the turfs as a coordination mechanism, as a way to get people to reduce their incentive to over-extract? And it works in theory. We've worked out the game theory of this, and it seems to work in theory, but could it work in practice? So we tried a thought experiment on the high seas. We just took it to the largest possible scale we could think of. You could think equivalently at a small scale in Vietnam, but we're talking about the high seas. And we did two things. We started by saying, and this is something Ragnvaldr Hannesson theorized about, 20 years ago. So we're kind of trying to build on his great insights. But the idea here was, could you extend exclusive economic zones? So they're 200 miles now. What if you went to 400 miles or 800 miles or 1,000 miles? And this is what it would look like. So let's see, this is 200, this is what we have now. This is 400. I think that's 800. And as you increase the size of the exclusive economic zones, and some economists would love to live in that world, right there, where there are no high seas. Everything is owned by somebody. Okay? Now, I think that raises a very interesting theoretical question. Which is better? Which is better from an efficiency standpoint? That one or that one? Or is it somewhere in between? What happens on the high seas? Well, it's basically open access. What happens in that world? There is no high seas, so there's not a single square meter of water that's open access, but we have the fish moving around problem here. Now you could argue that, well, maybe we could write contracts with the 47 other states, other countries that have bluefin tuna swimming around in their waters, but that sounds hard, and we haven't done such a great job at doing that in the past. So which one is better? So a colleague of mine and I analyzed this problem, and the way we approached it was we said, okay, for any extent of property rights, so for example this one, you have some area out, some high seas area, and you have to say what you're going to do with that high seas area. And we argued, well, either you can leave it open access, or you could completely close the blue area. So this is using the insight of the marine reserve in between two turfs to reduce the non-cooperation. So what if you what if we lived in that world? You extend property rights, but you close the remaining high seas area. Then what happens? Okay, so we simulated this. We tried to build a model that actually had real data on fish movement and real data on how hard countries fish on these high seas species. And let's try to make a prediction about the conservation implications, food security implications, economic implications of different configurations of the global oceans. Okay? Any predictions out there? Well, you can tell me if you predicted it right at the end, but basically what we found was that if you care about food security, so this is food security against the percentage of the whole global ocean in exclusive economic zones. So 0 would be, there are no exclusive economic zones. So the whole world is a high seas. 100 is, everything is pure spatial property rights. And what we found was that the best thing you could do if you care about food security is to have about 40% of maybe 45% of the world in exclusive economic zones, and the rest of the high seas completely closed to fishing. And if you believe the game theoretic model, that will maximize yield, fish yield, from the global oceans. Does anybody know how big our exclusive economic zones are now? Almost exactly that. It's like 42%. Okay, so it's sort of argued, don't mess with the EEZs, but you should do something about the high seas. Now, I think there's lots of issues that are debatable here. I'm just trying to be provocative. If you care about profit instead of fish yield, you get a similar result. Okay? And I'm sure there are many questions, and I'll take them in a minute. Let's see how I'm doing. Okay. Spatial bycatch solutions. So the only thing I want to say about this is I think there's a promising idea that, you know, if it's extremely expensive, as it is in the United States, and this turns out to be what we actually do, to pay college students to go out on every single fishing boat, on every single fishing trip, with a clipboard, you know, marking down what your catch is. If that sounds expensive, which it is, and if that's the only way to really be sure that you know what people are catching, and I realize the political morass that I'm getting myself into here, is it worth considering using a sort of a totally different approach where you have closed areas that are meant to protect the bycatch species, and you don't allow any fishing there, and then areas where you're going to allow fishing and you just don't worry about bycatch? Is it worth considering that alternative? We've started to analyze this problem. To my knowledge, it's never been formally analyzed by economists, but I think it's worthy of analysis. And then the last point here is on spatial conflict with other ocean uses, and this is really kind of an interesting one. It gets into really massive GIS analyses where you're trying to zone the oceans. You're allowed to do this here, and that's in conflict with these other things, so you can't do those. And this is just a figure from a paper by Sarah Lester that tries to do a trade-off analysis, a Pareto efficiency frontier across multiple different ocean uses, where each dot is sort of a different spatial plan. And one of the insights from that analysis is that things aren't always in conflict with each other. You can find efficient approaches to doing lots of different things. And maybe I'll just leave it at that. Okay, I'm going to conclude with a few, I guess I'd call them musings of my own about future directions that incorporate space into resource or fisheries economics. And I think, you know, most of these have been touched on by us and by our colleagues, but I really don't feel that these have been resolved. What is the optimal spatial scale of property rights? You know, when should the turf be this big versus that big? And what should the rules be within that turf? Or exclusive economic zone, for that matter. How do you effectively combine different kinds of spatial instruments? This is, you know, one example of that is the idea of a marine reserve with spatial property rights. Maybe you have an ITQ that is location specific, and that's sort of the case in the EU. I think at least it appears to be emerging. I think this is a really huge one. As we move to any form of property rights, there are going to be distributional consequences of that. And not just being able to measure those distributional effects, but mitigate the negative impacts of that distributional impact, I think is really critical, because at least I hear a lot of people, and I think in Europe this is an issue, you know, even if the pie goes from this big to this big, people don't like it if someone loses. And in principle, if the pie goes from this big to this big, we ought to be able to create the rights or allocate the rights in a way that nobody loses. So I think we need to do a better job of that as economists. How do you climate-proof institutions? If you rely on spatial property rights that are locked in, you know, you draw lines on a map and they never change, and they're relatively small, or they're smaller than the spatial scale of movement of species under climate forecasts, I think you might have a problem. because the species that used to live only in your country will soon be a straddling stock, and soon after that it will live in another country. If we can't even solve straddling stock problems now, how are we going to anticipate solving straddling stock problems when only one country is focusing on managing the resource? That's a huge problem, and I don't think we've really gotten a grasp on that one at all. Okay, this is the idea of insurance. People always talk about, oh, marine reserves, they provide insurance. But I think we need to be a little bit more precise. Insurance against what? How much insurance does it buy? Is there an economic value to that insurance, and should that be priced in? I think these are issues that people sort of talk about in policy forum pieces in science, but I haven't seen a lot of concrete analysis on that. And then going back to the bycatch issue, because I know it's such a huge issue here and in all countries that are really starting to institute property rights, when and how can we use spatial instruments? For example, just knowing what the overlap is of species, or where the heavy concentrations are of the bycatch species versus the target species, how much can that help us, and how should regulations respond to that? I have a PhD student who's done his dissertation on this subject and really found some interesting stuff, because in California, in the whole West Coast, we've implemented a multi-species ITQ program where every species is counted by the guy with the clipboard, and it's very expensive to implement, but he's been able to get tow level catch data of every fishing tow that's ever happened before and after the ITQ went in. And what he showed is that fishermen before the ITQ basically fished anywhere that it was profitable for the target species, without regard at all for the bycatch species. After the ITQ, they almost completely avoided the bycatch species, even though in the debate going up to that, everyone said, oh, it'll be impossible, we'll never be able to avoid these things. Well, as soon as there was a price on bycatch species, they immediately avoided them, and now, in fact, they're at about 15 to 20% of the total allowable catch for those bycatch species. So I regard that as kind of an economic success for multi-species ITQs, albeit very expensive to implement. That's what I have, and I thank you very much for your attention and look forward to your questions.
So thank you very much, Chris. That was extremely interesting. A couple of observations I have about optimization, and you were talking about hundreds of variables, no hope of being able to optimize, and taking an analytic framework. The thing that never ceases to impress me is that fishermen do this in their heads every day without the use of computers to one level of success or another. But certainly the people out there doing their optimization on a daily basis, I think we can learn quite a lot directly from them rather than sitting in our own offices trying to figure out how they think. I think we can learn a lot from actually going to speak to those people who do the mental optimization every day. The other thought I had about spatial measures is that I think maybe the use of those for bycatch management and so on and so forth can be quite different if you're in a sort of semi-crisis stock recovery situation than if you are in some kind of acceptable equilibrium. And in many of the situations we find ourselves in Europe, we're in a crikey, we've got to recover this stock now, or we've lost our chance forever. So sometimes it's quite a firefighting situation, and we've got belt and braces and input measures, output measures, overlapping measures, because we got ourselves into such a situation that that was the only choice. So we can take questions. I'm looking at some of our organizers. Have we got 10 minutes, 15 minutes? Nobody wants to volunteer? Okay, so we're running a little bit behind, but let's at least take 10 minutes of questions. So first here.
My name is Eckhard Bebke, and I have a basic question. If fish is a common property, some of the German fish belongs also to me, because I come from Germany, and my colleague has a small part of this fish. And these fish, my share, his share, and the shares of all my colleagues and other people is given for free to the fishermen. Why do you not say that they have, the management has to sell? It's the same problem what we have in the industry. A part of BMW belongs to me, and all the other shareholders installed a management, and they make money of that company and give me a part of that. Why isn't that organized?
Let me, I may have misunderstood your question, but let me try to take a stab at it. If I haven't addressed it, please correct me. So I think the question has to do with if the citizens own the fish, why are the fishing rights given out for free to fishermen? Is that, okay. So I just have a couple, I don't have all the answers, but, and maybe there are other people with answers, but I do have one thing to say about that. If most parts of the world that move from a common property or some kind of limited entry fishery to an ITQ system or a property rights system, the fishermen under the limited entry system before the property rights system, those fishermen are making some money. They have a stake in the fishery. And if there's a political process, so my answer has to do with political economy. If there's a political process where you have to get buy-in from those fishermen in order to switch to the more efficient system, then you can't make that, or I think it's very unlikely that you're going to get them to buy in if they are required to pay for all the rights, because they're making money under the current system, and then you're going to make them pay and not make money under the new system. So I think there's a political economy argument for why you would want to grant the rights for free, or at least some of the rights for free to those fishermen. Now, how much of the fishery you have to grant for free in order to make them better off under the new system than the old system is a debatable question. I've seen numbers like half of the fishery, not all of it. It's a little bit like allocating rights in a climate change agreement. You don't necessarily do it all for free. You may do half for free and auction off half, for example. So in my view, that's the right way to think about it. But I'm sure there are other ways to think about it as well.
Okay, so we'll go here,
Okay. My name is Fabrizio Natale from the Joint Research Center of the European Commission. Thank you for a very interesting presentation. Indeed, I don't have a question. It's just to confirm that I see there an enormous potential in using available data on spatial distribution of fishing activity, and the potential lies in the possibility of analyzing individual behavior while maintaining also a large scale of the analysis. So, for example, using the IS data, which is becoming available in the larger scale since the implementation of the obligation for having it on vessels above 15 meters in the EU, we can now see fishing grounds at the European scale and analyze individual fishing behavior for single vessels. So there is enormous potential for economic analysis using this kind of information.
Yeah, that's an excellent point, and I think that's sort of Hazel's point about fishermen are doing their own optimization. And as we learn more about how they're making decisions, we'll be able to do a better job of designing policy around it. So I thank you for your comment.
My name is Vahdet Ünal from Ege University, Faculty of Fisheries, Turkey. I have one statement on my German colleague, actually. The fish stocks is common heritage according to United Nations, but belongs to states. So states are allocating them to certain, the community, which is called fishers, by taking some money from their license. And they're using that money for the purpose of management of fishery and as well as the benefits of rest of the community. Okay, it belongs to us, but we have no right to do anything with the fish resources, because the state has that right on behalf of whole community. I think this is the explanation of me on his question, but there is a debate on that, of course. And my question is about the privatization of the marine conservation. To be honest, I couldn't understand very well your explanation and your statement or results on privatization of marine conservation very well. As an NGO, we started marine ranger system in a local scale in Turkey, southwest of Turkey, in the biggest bay of the Turkey. It works very well. It works very well. We have chosen the rangers from the fishing community. We have given them right and the time to choose, to decide whoever will be the marine rangers. But only the key point is the money, cost of the surveillance or cost of the enforcement. That if you pay as an NGO or as a state, all the costs rise from the marine ranger system, it works. Otherwise, fishermen don't want to pay for conservation, even though they see it works very well. Thanks a lot.
Thank you very much for that excellent observation, and I completely agree. And my experience in the developing world, mostly Southeast Asia, is exactly the same kind of thing. But even if you pay everything, they may not do it. So I think there's an incentive problem often. My only point, just to clarify, was that I think we often view property rights as a very contentious issue, and perhaps we view some people view property rights as in conflict with conservation. And the only point I was trying to make is that once you have property rights, whether they're ITQs or spatial property rights or any form of property rights, you have a platform for investment in conservation that you did not have before. Because if a fisherman does not have a right to anything and you pay him, he'll take your money, but he has no incentive he has no long-run incentive to do anything. If he has a property right and you write a contract with him that he'll do something, he has an incentive. That was my only point. But thank you for your comments.
John Turnbull, University of Tasmania. I apologise for my Australian accent. A great presentation, put up a lot of sort of mind thoughts which people might ask about. A couple of them. The tragedy of the commons question you started with, the work of course, Eleanor Ostrom, which everyone would know about, of course, discriminated this from the open access question on property rights. And when you got onto turfs in Chile, then I'm thinking, well, that's really what Eleanor wrote about just before she died. So I thought there was some separation here between your sort of comment about common property and Hardin's sort of view of that versus the more recent Ostrom stuff, worth considering. As one who works with marine ecologists and hydrologists and oceanographers on issues of this interface between science and economics, one thing that concerns me is the errors that they build into their models and the certainties of their models, particularly when it comes to climate change and even species movements across, for example, the Pacific. I just came from a situation, we're talking about swordfish, that we thought the swordfish off your east coast were the same swordfish off our east your west coast, our east coast, and now we're wondering whether they're two separate species. So that's my second question. My third one is about more of a professional question. It's about concepts like ITQs. We have often been criticised as a profession for putting out things of we should use ITQs or we should use turfs or whatever without the devil of the detail. As we know, you can buy an old Dodge truck in Iceland or in Ratchovich, and it won't have chains and it's got soil in the gearbox and it doesn't work very well. Or we can buy an Italian Ferrari. So they're both called cars. One doesn't work well, and often as a profession, I think we sometimes get criticised because of the old Dodge trucks that we put out there saying this is going to solve the meaning of life when they don't. So there's the sort of issues for you.
And I drive an old Dodge truck, by the way.
So do I.
Just kidding. Okay. Great points, and I mean, we should have coffee and talk. I guess maybe I'll just address the Ostrom. So I think on the ITQ question, absolutely I agree, and every time we talk about this stuff, we should say the devil's in the details, because it is, and we have to acknowledge that, but we're learning a lot about those details. So I don't think we can always hide behind, oh, well, we don't really know, because I think we do know a lot, and we should say what we know. And just the only other thing, I absolutely agree with your distinction regarding Ostrom versus Hardin. I think Ostrom had a lot to say about this space, and unfortunately she was at the end of her career when she was kind of acknowledged for being an expert at this, really. There's a guy, Nico Gutierrez, who wrote a really interesting paper on leadership and the idea of a cooperative, and that there were 3 features that made a fisheries cooperative successful: a strong leader, strong property rights, and some conservation zones. And I think that's more or less the story of Ostrom and fisheries economists over the last decade.